Welcome to Module 2, Lesson 4, Graphs of Linear Equations and Functions. Please pause this video and look at the 4 options. My question to you is which one doesn't belong and why? Some of you may have chose number 1 because it's the only graph of a line that extends through the entire graph, making it infinite. Some of you may have chose number 3 because it's the only graph that has a positive slope. Some of you may have chose number 4 because it's the only one that's a graph of a horizontal line, so it's the only one that has a slope of 0. In this lesson, we're going to be looking at a few key characteristics of the graphs of linear equations. First, let's take a look at the slope. The slope is a very key and important concept when working with linear functions. Our slope is our change in y over our change in x. There are many ways that you could find the slope of a graph. One of them is by using the slope formula, which is y2 minus y1 over x2 minus x1. In order to use this formula, you'll need the coordinates of 2 ordered pairs. Another way you could find the slope is by counting the rise over run on a graph. Let's calculate the slope of this line using rise over run. So what you're going to do is you're going to start with 1 point. We'll start here with 0, -5. And we're going to count how many we rise, meaning how many we go up, and how many we run, how many we move to the right, in order to get to the point 9, 0. So if we start from 0, -5, our rise is 1, 2, 3, 4, 5. So we rise 5, and we run 1, 2, 3, 4, 5, 6, 7, 8, 9. So our slope is 5 over 9. Make sure that you always check the direction of the line to determine whether the slope is positive or negative. So since our direction is going up, that means our slope is positive 5 over 9, right? So when you read a graph, you read it like a book. You read it from left to right. So we start from 0, -5, and from there, the graph increases. It travels upwards, right? That means that the slope is positive. If our line was going down from left to right, then our slope would be negative. So if you're using rise over run, after you calculate your rise over run, please make sure that you check the direction of the line to determine whether your slope is positive or negative. Let's take a look at using the slope formula to find our slope. We have our 2 ordered pairs here, 0, -5, and 9, 0. I'm going to label 0 as x1. I'll label -5 as y1, 9 as x2, and 0 as y2. Once you do this, all you have to do is substitute into the formula, right? So we'll have 0 minus -5 over 9 minus 0. 0 minus -5 is positive 5, and 9 minus 0 is 9. We get the same answer, the same slope, 5 over 9. Now let's take a look at the y-intercept, another very important characteristic of a line. Your y-intercept is the point where the line crosses the y-axis. Notice how the y-intercept always has an x-coordinate of 0. So if we look at our line here on our graph, our y-intercept is right here at -5. What about the x-intercept? Well, the x-intercept of a line is the point where the line crosses the x-axis. And for the x-intercept, it always has a y-coordinate of 0. So if we look at our graph here, right, our line crosses the x-axis at 9. So our x-intercept is 9. So let's write the equation. What pieces of information do you need to know in order to write the equation of a line in slope-intercept form? So let's recall our slope-intercept form, y equals mx plus b. M is the slope, and b is the y-intercept. So basically, if you know the slope of the line and the y-intercept of a line, you have enough information to write the equation of the line in slope-intercept form. So we identified our slope. We found our slope. It's 5/9. We found our y-intercept, which is -5. So we just substitute for m and b in our slope-intercept form. And our equation is y equals 5/9x minus 5. Please pause this video and work on the lesson 4 level 1 problems in the workbook. Moving on to level 2, our intermediate level. What if the equation is in standard form and maybe we need to put it into slope-intercept form, right? So the standard form of a line is ax plus by equals c. So let's take this equation here. -3x plus 12y equals 4. Now, there may be several reasons why, if you have an equation in standard form, you might want to rewrite it in slope-intercept form. Maybe you want to graph it and you want to use the graphing calculator, put it into y equals. Maybe you want to identify the slope from the equation. You won't always have to rewrite it in slope-intercept form. It really depends on the context of the problem, right? But let's take this equation here, -3x plus 12y equals 4, and let's solve it for y to put it in slope-intercept form. So we'll add 3x to both sides. Those cancel out, and we have 12y equals 4 plus 3x. Divide both sides by 12. Our 12s cancel out. And our equation reduces to y equals 1/3 plus 1/4 x. From here, we can identify our slope and our y-intercept, right? Our slope is 1/4, and our y-intercept is 1/3. Please pause this video and work on the lesson 4 level 2 problems in the workbook. On to level 3, our expert level. We're going to talk about parallel and perpendicular lines. So take a look at this problem here. It says, write an equation of a line that is parallel to the line whose equation is 3y equals x plus 6, and that passes through the point -3, 4. So we have a couple of things that are involved here, right? First, we need to ask ourselves, what do we know about parallel lines, right? Well, parallel lines, they have the same slope. So the first thing that you should do is find the slope of the line of the given equation. So we have our equation here, 3y equals x plus 6. And in order to find the slope, we need to put the equation in slope-intercept form. So if you divide both sides by 3, you get y equals 1/3 x plus 2. And if you notice, the slope of our line is 1/3. So if we're trying to write an equation of a line that's parallel to this one, we know our parallel slope also has to be 1/3 because parallel lines have the same slope. Now, the second part of the equation states that it's a line parallel, but it also passes through the point -3, 4, right? So -3 is our x value, +4 is our y value. So what we're going to do is substitute 4 for y and -3 for x and solve for the y-intercept of this parallel line, right? We're given the point -3, 4, -3 is our x value, -4 is our y value. We're going to substitute those values in, and solve for the y-intercept in order to get our equation. So 4 equals -1, right? Because 1/3 times -3 is -1 plus b. Now we use inverse operations, add 1 to both sides. We get b equals 5. So now we have our parallel slope, which is 1/3, and our y-intercept, which is 5. Those are the two pieces of information that we need to write our equation. We just substitute for m and b, and we get y equals 1/3 x plus 5. In the next question, we'll deal with the point slope form, okay? Write an equation of a line that is parallel to the line whose equation is 3y equals x plus 6, and that passes through the point -3, 4. Now, this is the same exact question. I'm just showing you a different way that you could answer it. So recall the point slope form, which is y minus y1 equals m times the difference of x minus x1. You should have learned this formula in geometry. So this form is called the point slope form. So what do you think you need in order to write an equation in point slope form? Well, it's all in the name. You need a point and a slope, right? So we have our point, which is -3, 4. And we would need our slope. We solved for the slope in the previous slide, right? We know the slope is 1/3. And then we have our point, like I said, -3, 4. -3 is going to be your x1 value. 4 will be your y1 value. So now we just substitute m, x1, and y1 into our point slope form. And we get y minus 4 equals 1/3 times the difference of x and -3. Now we can clean this equation up a little bit because x minus -3 is just x plus 3, right? And we get y minus 4 equals 1/3 times the sum of x and 3. Now you can leave your answer like this if it is an open response question. If it's multiple choice and your answers are in point slope form, you should be good. But just pay attention if you answer your question like this and your multiple choices are in slope intercept form, you will have to convert this equation into slope intercept form to get your answer. Let's take a look at one that involves a perpendicular line. Write an equation of a line that is perpendicular to the line whose equation is 3y equals x plus 6, and that passes through the point -3, 4. So we're dealing with the same equation and the same point, but now we're looking for a line that's perpendicular. So here's our equation, just converting it to slope intercept form because we're going to need to look at the slope here. So we know that the slopes of parallel lines have the same slope, but what about the slopes of perpendicular lines? Perpendicular lines have negative reciprocal slopes, right? So what's the negative reciprocal? Recall what we said the reciprocal is. The reciprocal is your fraction flipped. A negative reciprocal is your fraction flipped and the opposite sign, right? So since our slope here is 1/3, the perpendicular slope is going to be -3, right? Because it would be -3/1. The reciprocal of 1/3 is 3/1, and it's the negative reciprocal or the opposite reciprocal, which means you take the opposite sign. So we have a perpendicular slope, and now we're going to find the y-intercept, right? So again, what we're going to do is take our value of x and our value of y and substitute it into our slope intercept form, right? So 4, which is our y value, equals -3 our perpendicular slope, times -3, our x value, plus b, the y-intercept, which we're going to try to solve for. So now we simplify. 4 equals 9 plus b, and we use inverse operation, subtract 9 on both sides, and we get b equals -5. So now we have our slope and our y-intercept. So we can write our equation in slope-intercept form, and we get y equals -3x minus 5. Or you can choose to write your equation in point-slope form, and you would get y minus 4 equals -3 times the sum of x and 3. Please pause this video and work on the Lesson 4 Level 3 problems in the workbook. When you're finished with the problems in the workbook, you can stop this video and move on to the next video for Lesson 5.